Hello friends, welcome to Mohsin Mullah Interactive Tutorials. In this video we are going to see how we can obtain transient response of series RL circuit connected to a DC source. So now here I have selected a simple circuit as shown in this particular figure here. So it consists of a series combination of a resistor and inductor, and there is a switch connected which will be closed at time t equal to 0. This is applied by DC voltage source of 100 volt. So now we are going to obtain current flowing in this particular circuit as I of t, and theoretically we already know that this current I of t is given by V by R minus V by R into exponential raised to minus R by L into t. Okay, so now according to this expression, when we change value of t, we are going to get different values of I of t. So let us take one value as t equal to 0, and I of t will be equal to, so when you substitute t equal to 0, so exponential raised to 0, this term will become 1, hence V by R minus V by R equal to 0. So at t equal to 0 the current is 0. Similarly at t equal to infinity, current I of t is given by V by R minus e raised to minus R by L into infinity is e raised to minus infinity, which is equal to 0. Hence this term will be 0 and we will be getting only V by R. Therefore V by R is nothing but voltage divided by voltage of 100 volt divided by resistance of 10, which is equals to 10 ampere. It means that the current is going to change from 0 to 10 ampere. So the steady state value of the current will be equal to 10 ampere. Now when the switch is closed, so at that time the current will not be suddenly increasing to maximum value, because the inductor will try to oppose the sudden change in current. So that is called as the transient response. Therefore as the time increases or the time becomes more and more stable value, at that time the current will become stable. So here we can observe from this particular curve that the current is increasing from 0 and then it is reaching to a maximum value. Now one interesting fact from this curve is that the current reaches to 99% or higher than 99% of its value at fifth time constant. Okay, so that is what here the time constant for this RL circuit is given by L by R. So when we substitute L equal to 1 and R equal to 10, we are going to get 0.1 second as time constant for this particular RL circuit. Okay, so therefore fifth time constant is obtained as 5 into 0.1 second, that will be equal to zero point 0.5 seconds. It means that at 0 point 0.5 seconds the current I of t is going to reach 99% or higher value. Okay, so that is we are going to obtain practically and verify whether it is correct or not. So let us make the connections in software PSPICE schematics and check the same. Okay, so to make the connections we have to select the different parts. So first is DC voltage source. So select the DC voltage source, then place it somewhere here. Then we require a switch. So go to get a new part option, then type S. So there will be option of the switch T close, which is nothing but switch closes at T equal to 0. Select this, place and close. So we have to connect it in series here. So just place it somewhere here. So it will come here. Then we require a resistor. So select the resistor available here, then place it here. Then we require an inductor. So if inductor is available we can take, otherwise get a new part, that type L. So the inductor will be available in the first place. So select that inductor and rotate it before placing. So make it vertical, then place it here. Okay, so now we have to make the connection. So to do that we have to just zoom in the area to see the elements clearly. Okay, so now select this draw wire option, then click on one element, then go to this element, leave it, click, 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 and here also, and the same on the lower side. Okay, so circuit is closed. Now the circuit will be completed. So when we connect a ground connection here, so select this ground, available ground earth or ground analog, both are same. So do not forget to place the ground in this schematic circuit, otherwise the circuit will not be simulated and will not get the desired result. Now we have to change the values as per the required values. So voltage applied is 100 volt, resistance 10 ohm, inductor 1 henry. So let us make the changes. So type 100 volt, then resistance 10 ohm, and inductance is, so let us move here, inductance is 1 henry. Okay, now we want to see the current I of t flowing in this series circuit. So to see the current waveform, we have to select one current marker option available here. So current marker we have to select, and we have to connect it in anywhere on this series circuit. So usually it will be connected only when you place it on the blue part of the series connection. So either here or here you can connect. Okay, so when you make this connection, so it is ready to show the current flowing in this series path. So now we have to, before we simulate this circuit, we have to make certain setup changes here. So go to analysis, select setup, then we have to see the transient response, so click on transient. So we have to give the starting time 0 and end time as 1 second, because we have seen that the time constant is 0.1 second. So fifth time constant is 0.5 second, and 1 second is fairly good or large enough time to observe the waveform, current waveform. Now we can go for simulation, click on simulate, then we need to save it first. So type RL circuit 1. Okay, save. So you can see the waveform is available, otherwise it will be available on this lower ribbon here. So you can select this to see that waveform available here. Okay, so we can see it in a different way by clicking on this option, so alternate display. So you can clearly see the current is changing from 0 ampere and maximum value will be 10 ampere. So at fifth time constant it is going to reach to its 99% or higher value, which is visible here, but we have to see the value also. So if you see the scale here, it is 0.51, 1.5.2. So we can select particular 0.5 time. Okay, so for that we have to go back to the other display, then click on this toggle cursor. So it will be enabling these options to select a particular point on the waveform. So select this. Now when you click on this, so it will trace the waveform as you move the cursor. So move it till 0.5. So here it is 0.4, then 0.45, then this line indicates 0.5. So that is fifth time constant. Or here in this box also you can see 500 milliseconds is nothing but 0.5 seconds. So we have to see what value it has reached. So to see that, you click on this another option available here, mark label. So it will display the coordinates of that particular point. So first value indicates the time, second value indicates the magnitude. So the magnitude is 9.924, which is also displayed here, 9.924. So now 9.924 out of 10 clearly indicates 99.24%. So which is what we were expecting, that the current is going to reach 99% or higher value at fifth time constant. So clearly it has reached that particular value. So now we can change R and L value, and also we can determine a different time constant, and depending upon that time constant we can identify fifth time constant and verify whether the current is reaching to the same value of the current or not, like 99 or some higher value. Okay, so as here there are, we can say clearly, some disturbances available in this waveform. It is not smooth, so sometimes this value will be 99 point something, 243 or 4, etc. Okay, what is important is whether it is reaching 99% or higher value. Okay, thank you.